Okay, so what we're doing right now is taking a look at some of the areas that the Department of Education said that students had a hard time with on the EOCT. So we're taking a look right now about, this is number one. This is talking about renting a canoe. The cost is $3 for the oars and life preserver, plus $5 an hour for the canoe. This is a constant rate per hour, okay? Which means that this is going to be linear. It doesn't change, okay? If it was $5 for the first hour, $6 for the second, or something like that, then it's changing. But this is always $5 an hour. Constant rate equals linear. So you can go ahead and mark out A immediately, okay? Now then, as the hours go on, see there's 2 hours, 4 hours, 6 hours, 8 hours. As the hours go on, the amount of money should be going up. So D is not the answer. Now $3 for the oars. The only difference is that this amount, it's the same every time. It doesn't change according to the number of hours, which means the starting point is 3 and the rate of change is 5. So 5x plus 3. You're looking for something that crosses at 3. It's not that one. And that changes at a rate of 5. So the answer is C. Okay, moving to the next problem. Which scatter plot best represented a model of linear growth? Well, first of all, a linear scatter plot is going to look similar to a line. This one kind of curves. That doesn't look linear to me. That's sort of linear. This is all over the place, so it's not D, it's not A. And this one, they're all kind of in a line. So the question is, if you're comparing B with C, which one is the most linear? They're both kind of off, but then there's another word that if you missed it, okay, then you might have a hard time. It talks about growth, okay? And so this would be having to go uphill from left to right in the direction that you read, which means B is the answer for number 2. The next problem, number 3. Which graph most clearly displays a set of data for which linear function, for which a linear function is a model of best fit? Looking at this again, I told you that you've got to look at it and kind of see, does it look like the dots are getting in a line, kind of marching together in the same direction? That's a little bit. A little bit. B, not really. It's kind of just all over the place in a big box. D is also just kind of all over the place. Here we go, looking at A and comparing it to C. Okay, so let's move this and I will delete these other notations. We're pretty sure now, based on what we're looking at, that it's not going to be B. B is not linear. D sort of looks that way, but you've got all these outliers out here, so it's not D. C and A are both linear. You can tell that they kind of, it looks like things are headed in the same direction. C, it's more closely condensed, okay? The question was, which is best modeled by linear? And the answer is C. C is better than A because A is more spread out, okay? That was number 3. Question number 4. This graph plots the number of wins in the 2006 and 2007 season for a sample professional football team. Okay? Based on the regression model, what is the predicted number of 2007 wins for a team that won 5 games in 2006? All right, so this basically, somewhere in this region, okay, if you had to kind of draw a line where most of those points fit, it's going to be somewhere in here, okay? And so the question is, if somebody won 5 games in 2006, that's located right here. There's 5, okay? I'm going sideways. What would you expect their wins in 2007 to be? I would say it's going to be somewhere in between around 7 and 1, okay? And so we've got 0, that's not it. 3 is not it. Well, no, excuse me. 3 is possible. 8 is too high, and 10 is too high. So the answer is B, 3. All right? When they don't march in a perfect line, if you kind of make sort of a high and a low that gets most of them, then you can probably find something that's pretty close. Okay, so 3 is the best answer because it falls really easily in between there. It's not even close. So the next problem, we're only going to be doing 5 problems per video. A population of squirrels doubles every year. Initially there were 5. Okay, so 5 would be about right there. A biologist wants to study squirrels, created a function. 5 times 2 to the t. Okay, that's the starting amount. And this is the number that tells what happens. 2 means it doubles. If it was a 3, it would triple. Okay, so that's 5 initial squirrels times 2 to the t. What is the range of the function? Range, okay, and this is an important thing. In a graph, you need to label your axes, okay? And here, t, that stands for time. Time in years, okay? And P of t stands for the number of squirrels in this squirrel population. So the question is, what is the range of the function? Well, could you have 5 squirrels? Yeah, you started out with 5. It's asking you ever. Have you ever had 5 squirrels? Yes. Have you ever had 60 squirrels? Or will you in the future? Yeah, right there is 60. Have you ever had 80? Yeah. Have you ever had 100? Yeah. What about 1 squirrel? And the answer is no. From the very first measurement, there were 5. So 1 is not in the range. The range is this direction. Okay? The range is what happens to the output, the number of squirrels. Okay? And so basically, the range has to be greater than or equal to 5 because the squirrels, their population never goes down and you started measuring at 5. You're not going to have a negative number of squirrels. So is it any real number? No, because negatives are real numbers and so is 1 and 2, and it's not going to be one of those. Is it any whole number greater than 0? Well, theoretically, sometime it had 0, but see, time starts right here. The time starts when you measure, and when you measure, it's 5. So it's not any whole number greater than 0. Is it any whole number greater than 5? It's between C and D, and you have to be careful. Greater than or equal to 5. So the question is, from the very first measurement, was it ever 5? And the answer is yeah. The initial measurement at time t equals 0, when you went and counted squirrels, okay, there were exactly 5. So it's greater than or equal to, not greater than, because at some point it was 5. So the answer is D on that one. Okay, this is 1 through 5. I'm going to pick up again with 6 in the next video. Good luck.